Hi everyone, and welcome back to our Chapter 4 discussion of somatotypes in sport. This means we have officially reached the halfway point of Unit 1. How exciting! So without any further ado, let's get started. So we know from our previous discussions in Chapters 1, 2, and 3 that somatotyping is a way of classifying the general shape of an individual's body, with endomorphic individuals tending to carry more body fat, mesomorphic individuals tending to hold more musculature, and ectomorphic individuals tending to be more slender. While there are many different ways to formally go through somatotyping, for the purposes of this course, we're going to focus on the Heath-Carter method. What this is going to do is this method will rank each individual on the three different somatotype components. And then it will take each of these components and rank them on a scale of 1/2 to some number. So with individuals with endomorphy, this will go from a scale of 1/2 to 16 or more. Mesomorphy will go from 1/2 to 12 or more, and ectomorphy will go from 1/2 to 9 or more. Each of our somatotype classifications are going to describe a particular phenotype characteristic, and phenotype is the physical manifestation of your genotype, or your genes. So we know that an individual that sits more with endomorphy is going to have relative adiposity of their physique, so they're going to carry lots of body fat. Mesomorphy, this person's going to have relative musculoskeletal robustness of their physique. And ectomorphy, these individuals are going to be relatively linear and slender, in some ways petite with their physique. So I've a picture over here that you can see in your textbook. These are examples of extreme somatotypes. So all the way on the left, you have an extreme endomorph. In the middle, you have an extreme mesomorph. And in the far right, you have an extreme ectomorph. Now we know that people tend to lie within somewhere between these classifications, which is why we score people on all three components. So you notice in the text description underneath, for example, A was our endomorph, is marked 14, 4 and 1/2. This means they have a score of 14 for endomorphy, 4 for mesomorphy, and 1/2 for ectomorphy. This means that this individual is very clearly an endomorph. So this three-number system is going to kind of be able to have us triangulate between these different scales. So within this Heath-Carter method, there are some sub-methods on how we actually get those three numbers. And this is going to be established in three different ways. There is a photoscopic somatotyping procedure. This is going to use standardized somatotype photographs, which have front, side, and back views, and then a table of possible somatotypes with a given height, weight, and photoscopic criteria. So basically, you're taking individuals that have already been somatotyped, and we know their numbers, and then we're going to compare the picture to that. Well, that's helpful for some, but other times we want to be more specific, and this is where we use anthropometric somatotypes. That means we're going to use a somatotype rating form or some sort of equations. So as you can see here to the left, we have the Heath-Carter somatotype rating form, and we're actually going to take specialized measurements in the body, add this kind of information up, and this is going to give us their somatotype score. And then finally, there's a criterion method. And this is going to combine this photoscopic and anthropometric methods. If you can get away with doing this, this is probably going to be your strongest method for somatotyping an individual. So why does the somatotype matter to sports and performance? So as we've previously discussed in the first three chapters, we know a somatotype is going to give us some general physical characteristics, but it's only going to be one of many variables that indicate an athlete's ability to perform at the highest level. And since we know physique and therefore somatotypes play a role in self-selection in sport, there's so much literature out there linking somatotypes to particular sports and sports positions, even though there's typically not only one perfect somatotype for sport. So there is literature out there that says, well, this is the somatotype that's expected to perform well in the sport, but there can be multiple somatotypes. So this is where things get a little tricky. Another important thing that we need to discuss with somatotypes is the differences between males and females. This is called sexual dimorphism. This is the extent to which males and females differ with some respects in an external characteristic. and this external characteristic is going to be somatotypes. So in general, our high-level female athletes are going to be more endomorphic and less mesomorphic than their male counterparts. So why do you think it would be more important for females to carry more body fat than males? So take a moment, ponder. Yes, I hope you pause the video because otherwise it sounds like I'm crazy. But females need to carry more body fat for carrying pregnancy and having food to breastfeed, or fat as a fuel to breastfeed a child. So women just naturally, especially with the presence of estrogen, need to carry more body fat. That means regardless, with being female, there is going to be a higher amount of body fat present. However, knowing this, does this completely explain the differences between male and female performance differences? Kind of, sort of, but not really. So I would love to, if we were sitting face to face, to have this debate, but kind of think on that question. Next, we need to know the differences between athletes and non-athletes and their somatotypes. So we know high-level male and female athletes tend to be more mesomorphic, so they tend to have more muscle mass on that section of the somatochart when compared to individuals of the general population. While the general population tends to be more endomorphic and is randomly distributed across the somatochart. So the normal population tends to carry more body fat, the athletic population tends to carry more muscle mass, the athletic population tends to be clustered around a certain point in the somatochart, and the random general population tends to be more spread. So why do you think you would see this pattern? Another point to think about. So we also know that somatotypes are going to change over time. So different sports have seen changes in the preferred somatotype combination over time, while others have remained stable. Why? Well, first, athletes' self-selection into sport, in addition to more opportunities to participate, may shift the baseline sport population. So we have more variety in who actually gets to participate to start with. Then we may also see some specialized endurance training, which can shift away from endomorphy into ectomorphy. So how we train our athletes can force the body types we're seeing to change. Someone may come in that has a more endomorphic body type, but because I've trained them a certain way for endurance, they become more ectomorphic in character. Also, we have better understandings of nutrition, supplementation, and better food availability, which this may be shaping physiques as well and having us change to more efficient somatotypes. Finally, with our better strength and power training protocols, along with more available coaching for weightlifting, we can also kind of shift somatotypes more towards that mesomorphic character. So, something for you to do on your own. If you go through the tables that are posted on the next 3 slides that I'm just going to kind of quickly click through, and also review pages 55 through 64, I want you to kind of look at what the most desirable somatotype combination is for a particular sport. When we go into our next chapter discussions, I'm going to ask you to become very knowledgeable about 2 or 3 sports. I would suggest you kind of start identifying this information now through our somatotype discussion. So, as we can see here, this is our first table that shows preferable somatotypes. You have males in your middle column and females in your far right column. Here is your second, and here is your third. So, as with every discussion we've had up to this point, there's always exceptions to the rule. So there will be exceptions to standardized body size and shape. So it's not uncommon to find a successful athlete who does not fit the expected body shape or size expected for that sport. But the question becomes, when you have these unique individuals, should you try to alter their physique or leave it as is? And that is a question for a very experienced coach. Coaching is not only a science, but also an art. And there are times where sometimes it's just better to leave it be, and sometimes it's better to adapt. The next thing to kind of talk about is sports selection and somatotype. So we've talked about self-selection quite a bit. So athletes kind of just choose to go into sports that they know they're going to be good at. So it is a thought that athletes are said to self-select into a sport because at some point, typically as a adult or a child, they realize they have a particular talent for the sport or group of sports. Then athletes with the ideal body shape for that sport tend to do well and continue participation. So their body was well suited to the sport, they were having fun, they were doing well, they keep doing it. However, somatotyping has developed to the point that coaches and athletes may make reasonable forecasts of a child's reasonable success in that sport as an adult. So we can't fully predict what a child is going to look like somatotype-wise as an adult, but we can make some kind of assumptions. And then we kind of know when you're looking at an athlete that can kind of be successful in all sports they try, we have this ideal somatotype for the best all-around athlete. For a male, that is a 2-5-3 ratio, and for a female, that is a 3-4-3 ratio. And these individuals are demonstrated here on the left. So this is the ideal body type for your best all-around athlete. So we've talked about we have these ideal somatotypes, and then we can kind of change them, we can kind of predict them, but should we? And then we also talked about there's always an exception to the rule. However, if I do decide that a somatotype does need to be modified, we know that we can modify these with diet and exercise. So if an athlete is within 1 unit of the mean of this elite group of performers in their sport, so we talked about the 3-4-3 ratio. If they're within 1 unit, so let's say they're a 4-4-3 or something like that, it's not suggested that the athlete's somatotype be modified. They are close enough to that elite mean, just kind of let them be what they are. However, if an athlete is really far off of that mean for that elite group of performers, you may want to actually develop an intervention plan to adjust their somatotype slightly. So if you have an individual that is very far over on the endomorphic side, they're carrying a lot of body fat, these athletes may need to increase or decrease this component based on their performance group. So if it's actually found that this individual is underweight and it's unhealthy and they need to increase their fat mass, they can consume large quantities of complex carbohydrates along with some moderate protein consumption. They need to put on mass. All right. However, if we have the flip side where an individual is too heavy and I want to decrease their fat mass, they consume lower calorie diets and complete endurance training activities. If I need to modify an individual's mesomorphic character, which is usually a component most athletes wish to increase, basically I want to have low rep, high resistance strength training protocols and power exercises within my training protocols. And then finally, if you're wanting to work with ectomorphs, this change is going to happen whether you're messing with endomorphy or mesomorphy in general. So this comes to our final conclusion. Can I change my body type during growth? Can we predict a final adult somatotype from youth and adolescent data? Well, the answer there is kind of, sort of, maybe. There are some general trends in growth that we are comfortable making reasonable predictions for, like I had discussed previously. However, with exercise scientists and doing this with scientific data, we can make some predictions, but we don't have enough longitudinal studies out there to actually answer this question definitively. We also know that body type and body size can be variable across the lifespan, especially during puberty and adolescence, so we can get into kind of a tricky territory there as well. So, can we make predictions? We can try, but are they the best? We don't have the data to know. So, thank you guys so much for your time, and I look forward to hearing back from you guys for Chapter 5.